Chapter 6.1 is all about integers, and the key idea here is this definition that integers are any whole numbers, and that's going to be pretty important because whole numbers means we're not going to have any fractions or decimals. There are negative fractions and decimals, but those are a different category. So first of all, integers have to be a whole number, but then they can either be positive or they can be negative. So positive numbers are to the right of 0, and negative numbers would be to the left of 0, and both of those would be considered integers as long as, again, they're whole numbers here like we just talked about. And then 0 is also considered an integer, and 0 is kind of special because it's neither positive nor negative, so it's not positive or negative. And so we'll be using those terms. And another term you're going to hear in this chapter is going to be opposites, which by definition are the same distance from 0, but they're going to be on the opposite sides of number lines. So an example of that might be if we start talking about the number 2, then its opposite would be the same distance away from 0, which would be 2, but it would be on the other side of the number line, which would be negative. Or if we had another situation where we started with, let's say, a negative number. So if we started with -5, then its opposite would be, again, same distance away from 0, but on the opposite side of the negative, or of the number line. And since negatives are on the left of 0, then its opposite would be on the right, which would make it a positive number. For example 1, we're going to just practice writing positive and negative integers. So here's a word problem for you. It asks you to write a positive or negative integer that represents the situation. If a contestant gains 250 points on a game show, then we could represent that as 250, and since they're gaining it, that means it's a positive number, they're earning it. So you could technically put a plus sign, but more times than not, positive numbers will just have no symbol at all. So if you just see the number, it is automatically a positive number. Letter B says gasoline freezes at 40 degrees below 0, so we're going to start looking for keywords here, and obviously our number there is 40, and it's in degrees, but the fact that it's below 0 tells us we're going down on that number line. Think thermometers here. So we know it's 40, but since it's going down below 0 or to the left of 0, we have to put a negative sign, and you have to have that negative sign on integers that are below 0 in order to show that they're negative. Example 2 has us practicing graphing integers, and this is somewhat similar to what we were doing with the number lines in the activity for 6.1, but specifically make sure you watch for directions because it does say to graph each integer and its opposite. So every number line you do is going to have at least 2 integers on it. The first one, like for instance in this case it's 3, and its opposite. So you might want to just remind yourself right now that the opposite of 3 is -3 because you're going to need to graph both of those on your number line. So first thing you need to do is make sure you've got a number line that's set up, and again it's got to go at least past the 3 and the -3. Usually I encourage you to go at least, a couple of numbers past it so that you can see all around. And in this case we're going to make 0 the center of it, and then go ahead and graph 3 to begin with. So make sure that you don't have any floating dots or dots on a stick or anything like that. And then also don't forget the directions specifically said and its opposite. So the opposite of 3 would be the same distance away from 0, so 1, 2, 3, but on the opposite side of the number line, so that would be a -3. For letter B, they're asking us to graph -2, and again, don't forget you also have to graph the opposite, so we're going to remind ourselves that we're going to be graphing 2, and you can just set your number line up. Again, you don't have to go too far out. You can go at least 1 or 2 spots past where 2 would be on the number line, as long as everything's kind of set up in equal intervals. And remember, on the opposite side here, it's kind of mirror image, and then you can just go ahead and graph the -2 first. That was the original number they gave us. And then that was 2 spots away from 0. So then the opposite of -2 has to be 2 spots away from 0, but on the right-hand side. So we need both -2 and 2 graphed for this one. For example 3, we're doing a real-life application. It tells us that you deliver flowers to an office building, you enter at ground level and go down 2 floors to make the first delivery, then you go up 7 floors to make the second delivery, and it asks us to write an integer that represents each position. So you can set up something like this where you've got a list of the positions and it tells us that first you enter at ground level, so that was our first position. And ground level, of course, would basically be the 0 of this whole thing, because that would be kind of at level ground. And then it says you go down 2 floors, so if you can imagine the elevator moving up and down, then everything up would be a positive number and everything down would be a negative number, so that would be represented with a -2. And then for this final one, it says you go up 7 floors, so since you're going up this time, that would be a positive number moving upwards, and so you can just simply write 7 to represent that final piece of it. Part B asks us to write an integer that represents how you return to ground level from your final delivery. And to do that, we're going to go ahead and use a number line to model the movements that we made to make the deliveries. So where we first went in, of course, we went in at ground level. So we can kind of put that first. So that was ground level. Then it says we went down 2 floors. And so we can kind of track that on the number line to right here, and you can put a dot there or just a little line there that we went down those 2 floors, and then we went back up, it says 7 floors from this position, so we went 1, 2, 3, 4, 5, 6, 7 floors up, and that would have put us right here, which if you look at our number line, I've got it numbered every 2, but this would be the mark directly in between the 4 and the 6, so this would be at the 5th floor, and that must be where our second delivery was, since it was 7 floors up from the first delivery, which was down 2 floors. And so then the question specifically says for how we would return to ground level, what's our integer? So in order for us to get back from the 5th floor down to ground level to get back off the elevator, then we would have to go -5 or -5 for that particular integer. For this on your own set, you're going to graph the integer and its opposite. So just like we did in example 2, you've got to make sure that you get both the integer and its opposite on the number line. And I'll let you pick either the evens or the odds, so you can graph 5 and 7 or 6 and 8. Each one needs its own number line, so you need one number line for 5 to be able to graph 6 and its opposite. But then you would also need a different number line for 7 if you were going to do the odds, and you would have to put -12 at its opposite, or if you were going to do 6 and 8.